So the next concept what we are going to see is Gram-Schmidt orthogonalization process. So what this process says is every non-zero finite-dimensional inner product space has an orthonormal basis. So this is what this process says, and what we are going to do is if you are not provided with a set of orthogonal basis, then what we can do is we can able to find an orthogonal basis with the help of the given vectors, and with the help of that orthogonal basis we can able to normalize it to find an orthonormal basis. That is what the concept behind this orthogonal process is. So for this, what we you need to follow certain procedures. So take v1 as u1 and v2 as u2 minus the inner product of u2 comma v1 by norm v1 square into v1, and this is nothing but u2 minus projection of u2 under w1. Similarly, to calculate v3, the formula is v3 is equal to u3 minus inner product of u3 comma v1 divided by norm v1 square multiplied by v1 minus inner product of u3 comma v2 divided by norm v2 square multiplied by v2. So you need to follow the same set of procedures. So if you need to find another v4, then you need to put a subtraction sign here and again do the same set of procedure to find, so that the the new vi's which we have formed with this process will form an orthogonal basis, and with the help of that orthogonal basis we can able to easily construct an orthonormal basis. That is what the concept behind this orthogonalization process is. Okay, so now let us see a problem under this Gram-Schmidt process. The problem is consider the vector space R3 with the Euclidean inner product. Apply the Gram-Schmidt process to transform the basis vectors u1, u2, u3. This is u3 and not u1 into an orthogonal basis, and then normalize it to find an orthonormal basis to obtain q1, q2, q3. Okay, fine. So now we need to adopt our Gram-Schmidt process. The first step under Gram-Schmidt process is take v1 is equal to u1, that is equal to 1 comma 1 comma 1. Our next step is we need to find v2 and v3. So to find the value for v2, the formula is u2 minus inner product u2 comma v1 by norm v1 square multiplied by v1. And we know how to calculate this inner product between u2 comma v1 as well as this norm v1 square. So inner product between u2 comma v1 is equal to inner product between this u2 and v1. It means 0 into 1 is 0 plus 1 into second element is 1, third element into third element is 1. On the whole you will be getting 2. Similarly, norm v1 square is nothing but 1 square plus 1 square plus 1 square. So that gives you 3 as your answer. So that comes at 2 by 3. Okay, and it need to be multiplied by v1. v1 is nothing but 1 comma 1 comma 1. So just when you subtract these two, you will be getting the required vector minus 2 by 3, 1 by 3, 1 by 3 as v2. So similarly, we need to calculate the value for v3, and the formula is u3 minus projection of u3 under w2. So u3 minus inner product u3 comma v1 by norm v1 square into v1 minus inner product u3 comma v2 by norm v2 square into v2. Okay, so what is inner product between u3 comma v1? So in the question you are provided with the value for u3 as 0 comma 0 comma 1, and that need to be taken inner product with this guy. So you will be getting 0 plus 0 plus 1, so 1. Okay, similarly norm v1 square is nothing but what we have found out already. So it is 3. So you will be getting 1 by 3 multiplied by v1. v1 is nothing but 1 comma 1 comma 1. So that is what this second position value was. Next, you need to calculate u3 comma v2. So u3 comma v2, so that gives you what's the value for u3? It is 0 comma 0 comma 1. When you take inner product of that with this guy, that is v2 guy, what you will be getting is 0 plus 0 plus 1 over 3. So you will be getting just 1 over 3. And next you need to find a norm v2 square. So norm v2 square is nothing but root of square of individual elements. So 4 divided by 9 plus 1 divided by 3, sorry, 1 divided by 9 plus 1 divided by 9. So that gives you root of 6 divided by 9. So root of 6 divided by 9, sorry, root won't come because we are taking a square. So the square and root will get cancelled, leaving us the value. When you cancel this with the help of 3 table, you will be getting 2 divided by 3. So this 3 and this 3 will get cancelled. So what you will be getting is 0, 1, 1 minus 1 by 3, 1 by 3, 1 by 3. So here the remaining value is 1 by 2. When you take it inside, when you multiply inside, keep this minus outside. When you multiply this 1 by 2 inside, you will be getting minus 1 divided by 3, comma minus 1 divided by 2 3s are 6, comma 1 divided by 6. So when you add these three, you will be getting the value for V3. So now when you observe this V1, V2 and V3 will form an orthogonal basis. Okay, so let us check it. When you take dot product between this V1 and V2, so when you take dot product between this V1 and V2, what you will be getting is 1 into minus 2 by 3 is minus 2 divided by 3. 1 into 1 by 3 is 1 divided by 3. Similarly, here also you will be getting 1 divided by 3. So when you add all these things, you will be getting 0. So the inner product between V1 and V2 is 0. Similarly, the inner product between V2 and V3. So when you take inner product between V2 and V3, what you will be getting is minus 2 by 3 into 0 is 0. 1 by 3 into minus 1 by 2 is minus 1 divided by 6. So it is plus 1 divided by 6. On the whole, you are getting 0. Similarly, when you take inner product between V1 and V3, what you will be getting is 1 into 0 is 0. 1 into 1 by 2 is minus 1 divided by 2 plus 1 divided by 2. That is equal to 0. So with this 3, what we can tell is S is equal to V1, V2, V3 will form an orthogonal basis for R3. Next, we need to check whether this will form an orthonormal basis or not. So we need to calculate the norm for each Vi's. So the value for norm V1 is root 3. First itself it is ruled out. Here the norm value is not equal to 1. So we cannot conclude that S will form an orthonormal basis. So V1 is equal to root 3, V2 is root 6 by 3 and V3 is 1 divided by root 3. So what we need to do is we need to renormalize it to convert an orthonormal basis. So we have already discussed in the previous classes how to normalize any vector. Okay, so the formula to normalize any vector is the vector divided by its norm value. That is V1 divided by norm V1. So you will be getting 1 over root 3, 1 over root 3 and again 1 over root 3. And Q2 is V2 divided by norm V2 minus 2 divided by. So when you compute, you will be getting this, and for Q3 you will be getting this answer. So now when you take the norm for this Q1, Q2 and Q3, obviously you will be getting 1. So with this, what we can tell is this Q1, Q2, Q3 will form an orthonormal basis. Thank you.